Good morning. Today we are going to be talking about rates. Rates are ratios that have unit values that are different. So you're comparing two units and therefore you are looking at a rate. All ratios, let me backtrack that. All rates are ratios, but not all ratios are rates. Meaning that if you are doing a ratio that compares, for example, a part to a whole, you're not looking at a rate. If you're looking at a part to part, then you are looking at a rate. So that's something important to keep in mind. So the first thing we're going to talk about is, by the way, if you need to pause the video so that you can copy down the topic and essential question, please do so. But I'm going to move on to some key ideas. The first thing I want to write is a definition, and it states a rate, keyword, of two, or a rate is a ratio of two quantities using different units. Now, by different units, it means that you're measuring different things. So for example, and I'm going to circle that because it's really a key to the difference between a rate and a ratio. Different units meaning that if you're looking at like how much you would get paid per hour, you're looking at a currency amount for every hour, which is a time measurement. If you're looking at price per gallon, you're looking at a quantity versus a currency. So those are some examples of unit or of rates when you're looking at two different units that you're measuring. Now, also important to note is a unit rate. A unit rate compares a quantity to one unit of another quantity. And it's important to understand this one unit. So a good example of this I like to use is when you go to the grocery store and you're purchasing produce, you usually buy something per pound. That would be an example of a unit rate. It's per pound, per one unit. And then equivalent rates have the same unit rate. So they are equivalent rates are rates that have the same core value or the same unit rate, so that when you're looking at them, it's just an extension of that same unit rate. So let's do an example. So an example is that you pay $27 for 3 pizzas. We're wondering what the cost would be for 1 pizza. So to do that, you're going to first write the rate. To write the rate, you want to keep one unit over the other unit. So I'm going to do the cost, which is $27. This is currency. And then I'm going to do that over, so this is money, I'm doing money, over the amount of pizzas. So the amount of pizzas that we're selling. So that would be the rate. So the first thing you do is you write that rate. Now I'm going to make that equivalent to an equal fraction or an equal ratio or rate. To do that, we want to make sure that we're keeping the currency over the pizza, and we don't flip our ratio. It's really bad to flip your ratio because your values will change what it's worth. Now, what we do know is we want to find the cost of one pizza. So we're going to keep the pizza down here. But we don't know right now how much that would cost. Now, some of you might be able to do this in your head because it's a pretty simple problem mathematically, but it's important to understand the steps. So we wrote out our first rate that was given to us in the problem. Then we made that equivalent to a second rate using this value that we want to get to, which is 1. Now, because we're trying to find the cost for one pizza, we're going to be finding out the unit rate. So this is where we're going to find our unit rate, the cost for one. To do that, I'm going to simply make these like an equivalent fraction. So I've got 27 over 3 is equivalent to something over 1. What do I do to 3 to get to 2? So I'm going to look at this relationship that I have from this number to this number. And what I do is I divide by 3. So if I get 3 divided by 3 equals 1, just like we did in fractions, whatever you do to the top, you got to do, or whatever you do to the bottom, you got to do to the top, or vice versa. So now I've got 27. I want to divide it by 3. 27 divided by 3 would be 9. So that means that the cost of my one pizza would be, I'm going to erase this now, 9, and because we're dealing with currency, dollars. It's $9 for one pizza. So our unit rate would be 9 to 1, or you could do 9 to 1, or you could even write 9 to 1. Now let's look at one if we have an example where we're using a double number line. So we're going to write the rate that represents this double number line. So it's going to give you a double number line, and you want to look at it and write a rate that goes with it. So my first part of my number line, the line that goes out to here, and I'm going to have a second number line right here. So my second number line that I have, I'm going to have go the same amount. Now, I'm going to imagine that I'm playing a video game. In this video game, I get points. It's a musical video game. So for every note that I hit on the music video game, kind of like Rockstar, what's that, Rock Band? If I hit the note, I get a point. So we're going to count on the top my points, so I can get 150 points, I can get 300 points, I can get 450 points, I could get 600 points, I could get 750 points. And this is where I'm going to count my points, or my notes that I hit. So when I hit one note, or 2, or 3, or 4, or 5. Notice how they're spread, both number lines are spread evenly. I didn't have one down here that wasn't evenly dispersed point value wise as up above. That way they match up and I can circle them. So basically with this, what this means is if I hit 2 notes in the game, 2 musical notes, then I would get 300 points. If I hit 4 musical notes in the game, I would hit 600 points. And this information right here, this 4 points would refer to 4 not points, 4 notes. Apologize for that. 4 notes hit, it would equal 600 points. This is a rate. Now, if it were to ask you what is a unit rate for this double number line, you would go down here to where we have this 1 note hit, and we would circle here. This 1 value illustrates to us a unit rate. So our unit rate here would be 1 note equals 150 points. Now, with that information, that unit rate, I can now create data that goes beyond even my number lines. So I could look here and I could find these matches, but I could also say, okay, well, what if I get 8 points? Well, 8 points isn't on my number line. So I could figure, though, is, okay, well, if I get, for every 1 point, I get 100, or I keep flipping it, for every 1 note, I get 150 points. I can say, okay, well, what if I get 8 notes? How many points will I get? Well, what do I do to this 1 to get to the 8? Well, I multiply it by 8, right? Well, if I'm going to multiply the top by 8, I need to multiply the bottom by 8. So I would go 1 times 8 equals 8 over 150 times 8. And now I've got to do that problem, so I'm going to do it over here. 150 times 8. 8 times 0 is 0. 8 times 5 is 40. Carry the 4. 8 times 1 is 8 plus 4 is 12. So I get 120. So if I got 8 notes, I would end up with 1,200. Did I say 120? I meant to say 1,200 points. That's a lot of points. I'd be winning the game. So that's how you can use this double number line to find your unit rate, but make sure your unit rate is always that per 1 unit. That's the key. Alright, I need to flip my page, so I'm going to go over to the left to page 56. I don't know if it's the same in your notes, so you just kind of need to look to see what class period you're in, if you're the same. And so I'm going to look at now another problem. This one's going to be about space junk. That stuff floating in space, which, believe it or not, there's a lot of. We have space stations and different vessels up in space that release garbage into the atmosphere inadvertently or purposefully, but it's floating around up there. So space junk travels 5 miles in 8 seconds. It's a lot. I mean, imagine if you did that. Make your weekly mile run for PE a lot easier, wouldn't it? Space junk travels 5 miles in 8 seconds. How far does it travel per second? Alright, so I'm going to create a table. So the first thing I'm going to do is make a table. You could do a double number line if you wanted. You could represent your data however way you want to so that it's clear, but you want to do it some way that it's organized and it's clear. That's really important. Remember, we don't want to mess up our data. We don't want to put the wrong information in the wrong place, and we don't want to flip our ratio. So I'm going to have my distance, which is my first unit I'm measuring, which is in miles, over my time. It's a second unit, so we know it's a rate, which is measured in seconds. I'm going to create a line dividing them. Now I know that I have 5 miles for 8 seconds. So I've got 5 miles, 8 seconds. That's what I know. What I don't know is the unit rate, which is the per second, per 1 second. I don't know how many miles. That's missing. So we're going to look at relationships. I've got 5/8 is equivalent to something over 1. What do I have to do to 8 to get to 1? Right, I divide by 8. So if you had 8 divided by 8, you would get 1. So whatever you do to the bottom, you got to make sure to do the top. So now I've got 5 divided by 8 equals. Now, to do this, let's go over here. We're going to put our 5 divided by 8. Now, 8 cannot go into 5. It's too big. So I'm going to add a 0 and a decimal. And I'm going to annex a 0, add a 0 in there. Now, can 8 go into 50? Yes, it can go in 6 times. 6 times 8 is 48. Subtract. I don't know why I put it there. I got 2. Well, 8 can't go into 2, so we're going to add a 0. Can 8 go into 20? Yes, 2 times, which is 16. 8 times 2 is 16. Subtract, I get a 4. Got to keep going. Add a 0, and I get now 40. 8 can go into 40? Yes. 5 times. 5 times 4 is 40. Subtract, and I've equaled out. So, my answer here would be 0.625 seconds. Now, that is your very official answer. Now, I'm going to give you another way of doing this that would actually be simpler. If I've got 5/8 equals something over 1, and I don't know what it is, I could also write it as 8 divided by 8 is 1. So 8 divided by 8 equals 1 over 5 divided by 8. Because remember that when we write 5 divided by 8 this way, we could also write it with a fraction bar this way. They mean the same thing. So instead, I could have 5/8 of a second. So my answer here could be that it is space junk travels, and not in a second, 5/8 of a mile in 1 second. So I can write 5/8 of a mile, or if I wanted to be more exact, I could say 625 thousandths of a mile in a second. Still impressive. So if you have questions on this, make sure that you email me. You can talk to me, come see me after school, go back and watch this video again, but get the help you need and have fun with ratios and rates. I think they're a lot of fun. They're really useful as you figure out your mileage, or you figure out how much you're going to get paid in a salary, or even how much apples you want to buy in the grocery store. Rates are something that we use all the time. Thanks so much. Have a great day.